Hi everyone, welcome to PULLAS Academy. This is physics class for ECET students by Kiran Kumar Adarapu. Today we are going to discuss one chapter in our syllabus, that is elements of vectors. The blueprint of this lesson is 2 marks. Here we have to expect 2 questions from this elements of vectors. Okay. Today we are going to discuss part 1 video in elements of vector. Here in this video we will discuss about the introduction of elements of vectors. In this introduction we will discuss all basic concepts about the elements of vectors. We will discuss all basic concepts of vectors. Okay now? Right. So first I want to explain, first we will start from physical quantities. Okay, let us discuss about the physical quantities. We know what is physical quantities. All measurable quantities are called as physical quantities. Simple is called as, which are called as physical quantities. So the quantities which can be measurable, they are called as physical quantities. Okay, so here simple is called as measurable quantities. Measurable quantities are called as physical quantities. The quantities which can be measurable, they are called as physical quantities. So here which cannot be measurable, they are not called as physical quantities. Okay now? So here these physical, here in this lesson mainly we will discuss about the classification of physical quantities. So here we will discuss this classification based on the direction of the physical quantities. Based on the direction of quantities, the physical quantities are classified into 3 types. The first type is called as scalars. First type is what? Scalars is the first type. Next, second type is called as vectors. Third type is called as tensors. Okay, now we will discuss about the scalars. Second type is called as vectors. Mainly we will discuss scalars and vectors, and if you clearly understood, we have some more quantities, they are called as tensors. Okay na? Here important, which is scalar, vector. Some rare cases we have to identify which is tensor. Okay na? So this is a classification of physical quantities based on the direction of the vector. Okay na? ఒక physical quantity యొక్క direction ఆధారంగా, సో ఫిజికల్ క్వాంటిటీస్ని మనం 3 టైప్స్గా డివైడ్ చేయడం జరుగుతుంది. ఫస్ట్ టైప్ is scalars, which are called as scalars. Okay, now everyone know what is scalar quantity. Scalar stands, actually these are also physical quantities, but here they have only magnitude. Okay, so there is no direction for this explanation. Okay, now if you want to define this quantity or if you want to explain any quantity, there is no required direction. So it does not specify or it does not have any particular direction. It does not maintain any specified direction. Just here possible to measure accurately the magnitude of the quantities, they are called as scalars. Okay, now the physical quantities which has only magnitude but no direction, they are called as scalars. Clear? So ante a physical quantity ki aithe only magnitude maatrame undi, direction lekapothe వాటిని ఏమనాలి మనం? Scalars. That's the definition. Okay na? So here examples are important. That's why I want to give some examples of scalar quantities. Clear? So here do you know the examples? So many physical quantities we know. In these physical quantities, some have only magnitude, they have no direction, they are called as scalars or scalar quantities. Clear? So here one of the example is these fundamental quantities is considered as scalars. That means one example is mass is a scalar quantity. Okay, now next length is scalar quantity. Next time is scalar quantities. Okay, next temperature also scalar quantity. Temperature is also scalar quantity. Okay, now next after that density is scalar quantity. Density is what? Scalar quantity. Okay, next in the same way area also scalar quantity, volume also scalar quantity. Like this so many quantities. Okay now? So next one more is distance is scalar quantity. Next speed is scalar quantity. Okay now? Speed is what? Scalar quantity. Distance also scalar quantity. Next, one more example here. Next, speed of light is scalar quantity. Okay, now speed of not only light, speed of sound also scalar quantity. Okay, next, frequency is scalar quantity. Okay, next, one more is magnetic flux is scalar quantity. Electric flux also scalar quantity. Okay, now like this. Okay, now one more best example, one more important example is current or electric current. This is also fundamental quantity. This fundamental quantity is called as scalar quantity. So many quantities we have. At the situation, I want to explain that physical quantity is scalar or vector. When we introduce any physical quantity, is it scalar or vector? In our syllabus, where we introduced that quantity, I want to explain that is scalar or vector. But here not possible to discuss all physical, which are physical, which are scalars, which are vectors. It is not possible. At the situation, actually these are not countable quantities. That's why it is not possible to understand at one place. ఓకేనా, అంటే ఒకేసారి మొత్తం స్కేలర్ క్వాంటిటీస్ అన్ని చెప్పేయండి సార్ అంటే అలా దట్ ఈస్ నాట్ పాసిబుల్. ఓకేనా, అకార్డింగ్ టు ద సిచ్యువేషన్, ఇఫ్ యూ డిఫైన్ ఎనీ క్వాంటిటీ దట్ ఈస్ స్కేలర్ ఆర్ వెక్టర్, యూ హ్యావ్ టు డిస్కస్ ఇన్ దట్ వే ఇస్ ద కరెక్ట్ మెథడ్. Okay, I want to explain at the situation, but these are the important scalar quant. Sometimes simple questions are asking what is the simple questions. So in the given quantities, which is scalar, which is vector, that's the point. This is about the scalars. Okay, next we will discuss vectors. What are the vectors quantities? From this definition, very easily understood, the physical quantities which have both magnitude and direction and obeys the laws of vector addition, they are called as vectors. Okay, now the physical quantities which have both magnitude and direction and obeys the laws of vector addition, they are called as vectors. Okay, and a physical quantities kaite magnitude direction rendu undi మళ్ళీ లాస్ ఆఫ్ వెక్టర్ అడిషన్ అనేటువంటి ఖచ్చితంగా ఒబే చేసినప్పుడు మాత్రమే వెక్టర్స్ అని అనుకోవాలి. ఓకేనా, ఇఫ్ దే హ్యావ్ నాట్ magnitude and direction, they are not vectors. If they have magnitude and direction but it does not obey the laws of vector addition, they are also not considered as vector. These are called as vectors. One doubt you have, what is magnitude, sir? Magnitude stands quantity, don't confuse. So just here the quantity along with its units is called as magnitude. Indirectly understood, magnitude nothing but quantity. Quantity, okay, physical quantity and they have quantity. If they have quantity, they can be measured. Otherwise there is no required to measure the quantity. That means if you consider any quantity, any physical quantity, they have the quantity. That means if you consider any physical quantity, they have quantity. That means scalars have quantity, vectors have quantity, tensors have quantity. That means they have magnitude, they have magnitude, they have magnitude. But just they have not direction, they have direction. What is the difference? We will discuss. Okay, so this is about the vectors. Here also examples are important. What are the examples of vectors? Okay, so the best example of vector is displacement. Displacement is vector quantity. Okay, next, displacement similar quantity is distance. In the next lesson we will discuss clearly what is difference. Next, velocity, speed similar vector is velocity. Speed similar vector is velocity. Okay, now next, after that one more important quantity, that is acceleration. Acceleration is vector. Next, momentum is vector or linear momentum, it is also called as. Next, force is vector. Force is vector. Next, angular displacement is vector. Displacement and angular displacement also vector. Angular velocity also vector. Angular velocity is vector. Angular acceleration also vector. Angular acceleration, don't confuse, we will discuss each and every parameter in the next lessons. Acceleration is vector. Okay, So next, electric current is scalar, but whereas current density, electric current density is vector. That's the difference. Okay. Magnetic flux is scalar, but whereas magnetic field or magnetic induction is vector. Okay. So in this way, we will discuss so many quantities. These all are the vectors. Okay. One important point. So electric current, why it is scalar, sir? Why? Because electric current has both magnitude and direction, but it is considered as scalar. Okay. Why it is considered as scalar? Because electric current does not obey the laws of vector addition. If it does not obey the laws of vector, they are not considered as vector. That's why they are considered as scalar. Okay, now why? Because here, if we, at a junction, suppose two currents are enters into the junction, so then it does not follow the laws of vector addition. If you want to the resultant current, here it does not depending upon the direction. Okay, now here it does not obey the parallelogram law of vectors. We will discuss what is parallelogram law of vectors in this lesson. So that's why current is called, simple is called, it does not obey the laws of vector addition. That's why it is called as scalar. Okay, now so what is tensors? These examples you have to remember that. So asking some examples, very simple examples. Next, tensors. So tensor stands actually the physical quantities, which have different magnitudes in different directions. In different directions, they have different magnitudes, that is called as tensors. Okay, so we have some example. Tensors examples is moment of inertia. One important quantity is what? Moment of inertia. It has different directions in different magnitudes in different directions. It is denoted by I, moment of inertia. One more quantity is stress. Stress stands force by area. It is also tensor. One more quantity is surface tension. So these quantities have different magnitudes in different directions. That's why they are called as tensors. Just to recognize these points is enough. But here most concentrate. So which is scalar, which is vector is the important task here. Actually in this lesson we will discuss about the vectors. Okay, now here the topic is elements of vectors. So mainly we will discuss about the vectors. Okay, now so here first we will discuss how to represent the vectors. First we want to discuss about scalars has only magnitude, that's why there is no problem. It has only magnitude, that's representation is very simple here. But vector has both magnitude and direction. How to represent its magnitude and direction? Okay, now so that's why we need to understand the representation of vector. So that's why I want to explain representation of vector. So vector nu ఎలా రిప్రజెంట్ చేయాలనేటువంటిది ఇంపార్టెంట్. యాక్చువల్లీ హౌ టు రిప్రజెంట్స్ ద వెక్టర్, యాక్చువల్లీ a vector can be represented by a directed line segment, with a arrow head. So that is the representation of vector. Okay, now a vector can be represented by a directed line segment with arrow head is called as the representation of a vector. That means in this way represent, this is the line segment, a directed line segment, and with arrow end. So this arrow mark indicates the direction, and this length of this line segment stands the magnitude. This is a simple representation of vector. Actually it is represented by a directed line segment with arrow head. Okay, na? In for example, this is one vector, a bar vector here. So this is represented by like this. Suppose if a is a vector, if a means one quantity here, a is a vector, then it is represented by a bar. Write like this. This first write the symbol and a arrow placed above the symbol. So then you get a vector representation. This is called as representation of vector like this. Okay, now this is called as a line segment with arrowhead. Okay, now in this only this line segment indicates, suppose what is the length of this line segment stands the magnitude of the given vector. That's why here important is what is the point here? Magnitude of vector. What is magnitude of vector? Suppose here we consider a bar vector, so we call always bar, a bar. So magnitude of a bar vector is modulus of a bar, always indicated by modulus symbol. Why? Because magnitude has always measures positively. So this modulus always gives the positive value. That means the magnitude of the vector is always positive value. Don't take negative. So that if any vector represented by negative sign, that negative sign not represents the magnitude of the given vector. That negative sign only represents the direction of the given vector. That's why this is a magnitude of the vector is modulus a bar. That's the point here. Next, this arrowhead indicates the direction. So here you want to understand the direction of the vector. This direction is equal head arrowhead represents the direction of the vector. So this is about the representation of vector. Okay, no? So actually the length of this magnitude, it is represented like this. It is similar to what? Length of the length of the line segment. Line segment is stands, length of the line segment stands the magnitude, arrowhead stands the direction. This is a simple representation. Now we are going to discuss about the representation of direction. Okay, actually direction is represented like this. Suppose here in a plane consisting of this direction, suppose if you consider this is direction east, so then its opposite direction is what? West. Suppose if you consider this is north, then this direction is called as south. Okay, now these are the directions. Suppose any object moving along this direction, that is east, moving in this direction, it is moving along west direction, moving along upwards, that is called as north direction. It is moving downwards, that is considered as south direction. Along positive x-axis east direction, along negative x-axis is called as west direction in this one. And some more known directions here. These are the known directions. Okay, in a plane. So actually along straight line the directions is very easily understood. It is here possible only two directions. One is along positive x-axis, along negative x-axis. Positive x-axis direction, if you consider positively, in the opposite direction takes negative sign. By positive and negative signs very easily understood along the straight line. But in this space or in this plane, if you want to understood direction, understood this representation. Okay, now suppose if you want this direction, this is called as a north east direction, we have to consider. Okay, now in the same way this is called as what? Northwest direction. Suppose this corner stands what here? Southeast direction. Suppose this corner stands the southwest direction. In this way we have to understand. These are the representation of direction. And sometimes here given this not along northwest northeast direction. Suppose given vector like this. This is one vector. This vector passing along this direction. What is the direction of this vector? How can we understand? North direction is a known direction. So what is this vector? Makes some angle. Suppose it makes 30 degree with the north. Okay, na? So then from this point understood what is the direction of this vector. So this is a vector, it makes some angle 30 degree with the north. Okay, now then what you call this is, so here this angle is 30 degree east of north. What is this representation we call what? So the vector makes 30 degree east of north. Okay, na? With respect to the north, the vector makes 30 degree. So in this way understood. Otherwise the same vector, suppose 60 degree with east. So now we call this is 60 degree north of east. So the same vector 60 degree north of east. In this is a representation of direction. What is the direction of this vector here? 60 degree north of east. So with here this is not given this angle, so then we call 60 degree north of east. Otherwise given here one vector, so this vector makes 30 degree, suppose with west direction. So you want a direction, then what you call here, this is 30 degree north of west. Here with respect to the west, here it makes 30 degree north of west. In this way we have to understand. This is called as a representation of direction. I hope you understood. Now we are going to discuss about the representation of angle between two vectors. Okay, now to take the angle between any two vectors. Okay, if every vector represented by directed line segment. So suppose this is one vector. In this vector, this is a tail of the vector. This is the head of the vector. In a vector, this is the head of the vector. This is a tail of the vector. You want to the direction of any two vectors. These two vectors tails are these are placed at one. So these are placed at one place. Okay, now so then what is the angle between two vectors? Here it is two angles are possible. So this is one angle, this is some angle. For example, this is, I consider theta. This angle between these two vectors is theta. One more angle is also possible. So this is the one more angle. Okay, now so this is what is this angle here? This is theta. So then this total angle is 360. That means this is 360 minus theta. These two angles are possible between these two vectors. Okay, now if the two vectors are displaced with tail to tail, then the which is a smaller angle in these two, that is considered as a representation of angle between any two vectors, which is a smaller angle, that is considered as the angle between two vectors. ఏవైనా రెండు వెక్టర్స్ యొక్క టైల్స్ ను టచ్ చేస్తూ ఉంచినప్పుడు ఆ రెండు వెక్టర్స్ మధ్య యాంగిల్ అనేటువంటి టూ యాంగిల్స్ అనేది ఇక్కడ పాసిబుల్ అవుతుంది. ఈ టూ యాంగిల్స్ లో వన్ ఇస్ smaller angle, one is larger angle, but this larger angle is not considered as angle between two vectors. It is wrong. Only which is smaller, that is only considered as angle. In this way we have to understand. So where we take the angle? If the tiles of two vectors are intersect at one point, so then what is angle between two heads of these two vectors is considered as angle. This is the procedure. But here given this example, what is angle? Suppose given here angle between here, this is given theta, but here theta is not considered an angle between two vectors. This is a smaller angle between these two vectors, but it is not considered. Why? Because here these two tails are not touched to each other. Only one, this is one tail, this is one head is touch to each other, but this is not considered as angle between two vectors. In this way confusing in the question. Then how can you possible to measure? So this vector is, suppose this is a direction. If you slide it parallel by itself, this vector is slided parallel by itself, there is no change its direction or magnitude. So suppose this vector is slided parallel by itself, there is no change. When it is parallel, when it is slided, now this tail of this b bar vector, this is tail of a bar vector coincide here. What is angle this remaining as? This is, if you consider theta, total angle is 180. Then here 180 minus theta is considered as angle between two vectors. What is angle between a bar and b bar vector? 180 minus theta. If given like this, okay na? Right. Suppose if given two vectors here like this, this is one vector, this is one. So from this two vectors understood, these are in the same direction. They are in the same direction. Okay na? If they are in the same direction, so that is called parallel to each other. These two vectors are parallel to each other. If they are parallel to each other, always consider as 0 degree. The angle between two parallel vectors are always considered as 0 degree. If two vectors passing along the same straight line, that's also angle 0 degree. Otherwise, they are in the same direction like this, that is also parallel. Here one point for representation of angle. So what is when the vector is changes, when the vector is not changes. So here you have to understand these points here. Okay, now so here the point is translation of vector. By translation of vector, when vector is changes, when it is not changes. Suppose here this is one vector. This vector is, suppose this vector is slided parallel by itself. Slided means it is slided to here parallel by itself. Then there is no change its magnitude and direction. Direction is same. Just it is slided here from this is a bar vector. Now it is also a bar vector. Just it is slided parallel by itself. There is no change its direction and magnitude. That means the vector does not change. Okay. If a vector is slided parallel by itself, then it does not change. That is one of the condition. Okay. Next, but if the vector, suppose this is a vector, a bar vector, suppose it is rotates in anti-clockwise direction from this position to this position. It is also a bar vector, but it is rotates with some angle theta. So now what is changes? The direction is changes. This is initial direction. Now this direction makes some angle theta with the initial direction. That's why now the direction is changes. Vector also changes. In this case, vector is changes. Okay. If a vector is rotates, then its direction is changes. That means the vector is changes. Otherwise, it is rotates in 360 degree. There is no change its magnitude and direction. Okay. If it rotates some angle, then vector is changes. Okay. If rotates, direction is changes. But here it is slided parallel by itself, no changes. That's the important points for representation of angle. These all are the basic concepts of elements of vectors. Okay. Now we are going to discuss some previous ECET questions related to this topic. Okay. This topic related ga konni previous questions. ఇదే టాపిక్ రిలేటెడ్ ఎలాంటి క్వశ్చన్స్ ప్రీవియస్ ఎగ్జామ్స్లో మనకు క్వశ్చన్స్ అడుగుతున్నారో మనం ఇక్కడ డిస్కస్ చేద్దాం. ఓకేనా? రైట్. సో హియర్ ఫస్ట్ we will discuss question number 1 is asking in ECET 2010. This question is repeated in ECET 2010. So what is question? Simple question here. Which of the following is not a vector? In this given 4 options, which of the following is not a vector? Is not a vector means what? Scalar. That means it is scalar. It is not a vector. That means here observe. First one is magnetic flux. Already I explained magnetic flux is a scalar. That's why it is not a vector. This is a correct answer. Just simply understand. So if you observe the remaining options, okay? ఎలా చెక్ చేసుకోవాలి మనం ఏదైతే సెలెక్ట్ చేసినామో కరెక్ట్ కాదు. సో వీ హ్యావ్ టు అబ్జర్వ్ ద రిమైనింగ్ ఆప్షన్స్ ఆల్సో. సమ్ టైమ్స్ 2 ఆప్షన్స్ ఆల్సో గివింగ్ కరెక్ట్. సో దట్స్ వై యూ హ్యావ్ టు చెక్ వన్స్, దెన్ you get the clarity. Next, magnetic induction or magnetic field is vector. Magnetic force also vector. So none means what? Here all are suppose scalars, we have to select. That's why, so these 3 options are wrong. Which is correct here? Magnetic flux is a scalar. That's why it is not a vector. This is a suitable answer. Next, second question. This is repeated in ECET 2009. It's also very simple question. Which of the following is a vector quantity? Which of the following is a vector quantity? Given 4 options. One is charge, second one is electric current, third one is electric density, fourth one is electric potential. Electric charge is a scalar. Already we have discussed. This is charge is scalar. Next, current, electric current is scalar. Why it is scalar? It has both magnitude and direction, but it does not obey laws of vector addition. Here maximum students are confused, but electric current has both magnitude and direction, but it does not obey the laws of vector addition. That's why electric current is considered as scalar, not vector. That's why it is not correct. But whereas electric current density or simply is called as electric density. So this electric density is vector. Okay, now what is electric density? Electric density J is equal to electric current per unit area. Okay, now so but it is considered as vector. It is not a scalar electric density. Okay, now next, whereas electric potential is scalar. In our electricity concept, we will discuss clearly each and every parameter. It is scalar. It is scalar. It is scalar. This is only vector. That's why this is the correct answer here. Which is suitable here? Third one. Next one is the same model questions, previous model questions. Here one question is, of the following the vector quantities. So in the given 4 options, the vector quantities, which is vector quantity? So already from these options understood, time is a scalar quantity and fundamental quantity. Electric current already I explained, this is scalar. Okay, next, velocity of light and speed of light in vacuum, velocity of light in vacuum, or velocity of light, or speed of light, or velocity of velocity of sound, speed of sound, these all are same, they are scalars, because they are also have this velocity of light has both magnitude and direction. It is also does not obeys the laws of vector addition. That's why given maximum students are confused, it has direction, that's why it is vector. They understood it is vector, but it is not vector. Why? Because it does not obeys the laws of vector addition. ఈ రెండు క్వాంటిటీస్ కి మాగ్నిట్యూడ్ డైరెక్షన్ ఉన్నప్పటికీ ఇవి వెక్టర్ అడిషన్స్, లాస్ ఆఫ్ వెక్టర్ అడిషన్ ఒబే చేయరు కనుక ఈ రెండు క్వాంటిటీస్ ని మనం వెక్టర్స్ కాదు స్కేలర్స్ గా కన్సిడర్ చేయడం జరుగుతుంది. Whereas it is nothing but one force, gravitational force, electric force, magnetic force, these all are nothing but force. That's why it is called as vector. That's which is correct here. Gravitational force is the correct option. This is analysis. So we have to observe each and every option is which is this answer is this is the answer for which question. If you understood, so then you got clarity. That's the concept here. Next one is, now we are going to discuss about question number 4. Here choose the correct statement. The first option is temperature is a scalar but temperature gradient is a vector. Actually temperature is scalar already, so we know that temperature gradient stands temperature difference per unit length is that is called temperature gradient. So this is called as vector. Okay, now per unit perpendicular distance is a particular scalar vector quantity. That's why temperature gradient consider as vector. Okay, now so this is correct here. And velocity of a body is vector, but velocity of light is a scalar. That's correct. Velocity is vector, velocity of light is scalar, but because it does not obey the laws of vector addition, that's why it is also correct statement. Third option, electric intensity means electric field is vector, and electric density means electric current density is also vector, are vectors, both are vectors. That's the third option also correct. That means all the above is the correct option. Okay, now this is one type of model questions on this related topic. Okay, now these are the different questions on this introduction topic. Okay, now in the next class we will discuss the next concept of this lesson. Okay, now so thank you, bye, have a nice day.